Hello everyone, welcome to our channel Assemble to Learn. Friends, this is the part 2 of OAVS PGT Physics previous year questions discussion. Okay, so let's start our question number 11. So in question number 11, what is given in A? Which type of evaluation a teacher conducts a quiz to motivate the students to what more in number? Which type of evaluation and what is more? Means first option is summative, participative, second is diagnostic, participative, third formative, learn, diagnostic, learn. In a summative evaluation, a teacher conducts a quiz to motivate the students to participate more in number. And second, in a diagnostic evaluation, a teacher conducts a quiz to motivate the students to participate more in number. Learn more in number, not possible. Participate or participate. Summative evaluation or diagnostic evaluation. In diagnostic evaluation, teacher conducts a quiz to motivate the students to participate more in number. So option 2, that is diagnostic and participate, is correct. Okay, then next question, question number 12. Question number 12 is in completely elastic collision. One second. In a completely inelastic collision, what happens? The two particles move separately after the collision, but the kinetic energy is lost. The two particles move together after the collision, only some of the initial energy is lost. The deformation during the collision is partially recovered. In completely inelastic collision, the two particles stick to each other. That means the two particles move together after the collision. That is option number 2 must be correct. Okay. Next, question number 13. The equivalent EMF of a series combination of N cells with EMF E1, E2, En and internal resistances R1, R2 up to Rn is. What is asked here? Equivalent EMF. We have to calculate equivalent EMF. So different EMF are given. N cells, EMF of N cell E1, E2, E3, E4 like that up to En. So equivalent EMF, E equivalent is equal to E1 plus E2 plus E3 up to ... En. Okay, and it is given in the first option. Equivalent EMF is equal to E1 plus E2 plus up to En. Okay. Then question number 14. Question number 14 is, consider a body of mass m is moving down a rough inclined plane of angle of inclination alpha, and the coefficient of friction of the plane varies with the distance moved by the body x is equal to x. Mu x is beta x square by 2, where beta is the constant. Net force on the body is 0 at x is equal to L. What is the value of beta? First of all, we have to consider a body of mass m moving down a rough inclined plane. Let's draw a inclined plane. Suppose this is our inclined plane, and the angle of inclination is alpha, and the coefficient of friction of the plane varies with distance. Mu x is equal to beta x square by 2. Beta is constant and net force is 0, means F net is equal to 0 when at x is equal to L. When the distance x is equal to L, then F net is equal to 0. Then we have to calculate beta. Let's consider a body of mass m over this rough inclined plane. Like suppose this is the body of mass m. This is the body of mass m. Then what kind of force are acting on this? It is inclined, means the F net force is here in downward direction, and frictional force must be the upward direction frictional force, and in this direction normal reaction is there, and in this mg weight mg is there. Then two components of mg, one is this and one is this. If there are two components of mg, this one is mg sin alpha and this one is mg cos alpha. Okay, this is alpha. If this is alpha, then this is also alpha. Then all these are acting on this body of mass m. All these forces are acting on it. Now if we find out the equation for net force, then F net is equal to mg sin alpha minus frictional force. Okay, so F net is equal to mg sin alpha minus frictional force, and as we know, frictional force is mu times of normal reaction. Here mu is given as beta x square by 2 and normal reaction, and also normal reaction balances the force, that is this force mg cos alpha, mg cos alpha. Okay, so we can write here in place of frictional force beta x square by 2, and in place of n capital mg cos alpha. Okay, then there is a condition that F net is equal to 0 at x equal to L. That means this must be equal to 0 when mg sin alpha minus beta, in place of x we put L, beta L square by 2 mg cos alpha. Then we can write mg sin alpha must be equal to beta L square by 2 mg cos alpha, right? Then mg and mg cancel with each other, and sin alpha divided by cos alpha, here we can write tan alpha is equal to beta L square by 2. We have to calculate value of beta, and from this equation we can calculate beta is equal to 2 tan alpha divided by L square. Let's check from options. Here option 3, that is 2 tan alpha divided by L square. Option 3 is the correct one. Okay, this is our answer, value of beta. Next, question number 15. This is methodology question. A science club helps to improve hands-on experience of science students, improve verbal skills, no. Verbal skills not possible. Writing skills, no. Hands-on experience, okay, but grow the creativity of the science student, this is the better one. So a science club helps to grow the creativity of the science students. Next question, question number 16. If the resistance of the platinum wire of a platinum resistance thermometer at the ice point is 5 ohm and at the steam point is 5.3 ohm, then the temperature coefficient of resistance of the wire is. There is a formula for calculating temperature coefficient if two different point resistance is given. That means here ice point, let ice point resistance is R0 or R at 0 degree. I can write R0 is equal to 0 degree, that is equal to 5 ohm. Then at steam point, at some temperature T, that is equal to, let steam point 100 degree, then here 5.3 ohm. Okay, then we have a formula, resistance at any temperature is equal to resistance at initial temperature R0, or suppose this is the ice point and this is the steam point, whole into 1 plus alpha delta T or T minus T0. Okay, so here if we check temperature is 100 or 0, 100 and 0, so and RT is resistance at that temperature, higher temperature is 5.3 is equal to R0 value is 5, 1 plus alpha, here alpha is the temperature coefficient of resistance and we have to calculate alpha, T minus T0, T0, that is 100 minus 0 is 100. Okay, now 5.3 divided by 5 is equal to 1 plus 100 alpha. Now 5.3 by 5 minus 1 is equal to 100 alpha. That implies 5.3 minus 5 is 0.3 by 5 is equal to 100 alpha, and alpha is equal to 0.3 by 500, that is 3 by 5000, right? Or 3 by 5, suppose in 3 we add one more 0, then 30, and here this, so 5 into 6, 30, so 6 into 10 to the power minus 4 and degree Celsius. Okay, so by degree Celsius, option, if we see the answer, then 7 into 10 to the power minus 4, 4 into 10 to the power minus 4, and option 3, that is 6 into 10 to the power 6 into 10 to the power minus 4. Third option is the correct one. Okay, value of alpha. Then next question, question number 17. If a car of mass capital M moving with uniform velocity v for a time interval t, the net force acting on the car. Net force acting on the car. Force is given as mass into acceleration, but here mass is given as capital M. Okay, but the car is moving with uniform velocity. Uniform velocity, that means constant velocity. If the velocity is constant, what is acceleration? Acceleration is change in velocity, and change in velocity a vector. Acceleration is dv by dt. If the velocity is constant, then acceleration is 0. So force, net force acting on the body is 0. Option 4 is the correct one. Then question number 18. What is given? A 100-watt bulb is on for 10 hours. The energy consumed by the bulb is energy consumed by the bulb. What is how to calculate energy? Power into time taken. So energy consumed is equal to 100 into 10 watt hour. So this is 1000 watt hour. It is 1 kilowatt hour. Okay, but in the options, all the options are given in joule. So if we convert 1 kilowatt hour, it gives us 3.6 into 10 to the power 6 joule. Okay, so this is very easy. You can calculate this, how to find out one value of 1 kilowatt hour in joule. Okay, next question number 19. The difference between the specific heats for a given gas is 3000 joule per mole degree Celsius, and the ratio of these two specific heats is 2.5. What are the values of the two specific heats in kilojoule per mole degree Celsius? Okay, so here difference between two specific heats of a given gas, Cp, Cp, okay, or Cp. So let difference between the specific heat. Suppose Cp minus Cv is given as 3000 joule per mole degree Celsius. Okay, and the ratio means Cp by Cv is also given as 2.5, and we have to calculate value of Cp and Cv, right? From this we can write Cp is equal to 2.5 Cv. If we put this equation 1 in this equation 2, then using 1 in 2, so Cp, in place of Cp we can write 2.5 Cv minus Cv is equal to 3000 joule per mole degree Celsius. Then 2.5 minus 1, that is 1.5. Cb is equal to 3000. Then Cb is equal to 3000 by 1.5, we can write 15 in 10. Then 2000, 15 into 230, and 2000 joule per mole degree Celsius. Okay, then Cb is this. Now Cp is equal to 2.5 into 2000, that is 5000. 2.5 into 2, 5, and 5000 joule per mole degree Celsius. And okay, option yes, the two specific heats in kilojoule per mole degree. Kilojoule, here we found joule. 2000 joule is 2 kilojoule per mole degree Celsius, and this is 5 kilojoule per mole degree Celsius. Okay, so answer is option 4, that is 2,5. Okay, now next question number 20. If a charged particle Q is moving in a constant magnetic field of B naught k cap with a velocity of v is equal to v naught I cap plus k cap, then the Lorentz force on the charged particle is what? Lorentz force, as we know, F is equal to QVB sin theta, or we can write QV vector cross B vector. A cross B, AB sin theta, so VB sin theta, V cross B. This is our Lorentz force. Now what is given? Q is given, charge particle Q is moving, magnetic field is B naught K cap, and V is V naught I cap plus K cap. Let's put Q V cross B. B naught K cap cross, okay. Now yes, Q and this is one second. Okay, V cross B, and we have V, value of V is V naught I cap plus K cap cross B naught K cap. Okay, now Q whole into V naught B naught and I plus K cap cross product with K cap. So V naught I cap cross K cap plus V naught B naught V naught, and here also V naught B naught K cap cross K cap. Okay, now Q I cross K is minus J cap, so minus B naught V naught J cap plus K cap cross K cap is 0, so this one. So final answer is minus Q B naught V naught J cap, and it is given in the option KJJ, minus Q B naught J cap. Okay, option 3 is the correct one. Okay, this is the last question number 20 for today. Thank you for watching.